Hi, everyone. My name is Maria Ellis, and these are my 6 team members, Lily, Emily, Neil, Sam, Jaru, and Dan. And we are Team 3D Printing Silicone, sponsored by Medtronic. Medtronic is a global leader in medical technology, services, and solutions. A critical part of Medtronic's product development process is creating realistic anatomical models for testing new devices. These anatomical models must be a 3D printable, durable, tissue-like, transparent material for the best results. Meeting the demands for the best anatomical model has been a challenge. Medtronic's goal is to create a silicone anatomical model that is 3D printable, durable, tissue-like, and transparent to yield more accurate lab results.
So we printed parts by the Formlabs Form 2 printer in our lab. The Formlabs Form 2 printer is a professional SLA desktop printer preferred by Medtronic. It provides an open source mode which aids in the investigation of silicone printing on the Form 2 printer. As you can see in figure 2, we printed the aortic root, that is the part desired by Medtronic. We first used the Elastic 50A resin to print this part. We used various printer settings, print washings, and different form cures. Then we used a third-party resin called UltraCure resin, which had a shore hardness of 30A. We used the open source mode for this resin because it's not traditionally paired with the Form 2 printer. However, our print yielded good results. As you can see in figure 4, we printed a successful disc. Lastly, we ordered parts by third-party companies, one of them being Spectroplast. This company provided samples with high tensile strength, good elongation at break and tear strength. It's also biocompatible. We also ordered samples from ASIO, which provided transparent, flexible, durable, high sterilizability, and biocompatible materials. After we ordered the materials, we wanted to do some mechanical testing on them. In, in figure 5, you can see the plot of mean and standard deviation of peak stress, initial modulus, and strain at break for the UltraCure Elastic 50A and ASIO samples. This result yielded that the UltraCure was a happy medium between the Elastic 50A and ASIO samples with regard to durability and flexibility. We then did a swelling test, and we did this to see how much water the samples absorbed. As you can see from the graph, the ASIO absorbed the least amount of water over day 1, and the Elastic 50A absorbed the most amount of water over day 2. Finally, we did a transparency test. We found that the ASIO samples were the most transparent compared to the 50A and the UltraCure samples. Overall, after doing all of these tests, we think that the ASIO resin would be the best to suit Medtronic's needs. Thank you for listening.